Hi everyone, my name is Chetan Gadgil. I am part of Intel's Internet of Things group as a part of a business unit called Markets and Channels Acceleration. So I mainly focus on market ready offers and what we are calling as RfP ready kits, which I'm going to shortly speak about. As you'll see, this is more about developing and deploying commercial applications, not just maker grade stuff. And you'll see some of those differences in the examples that I give you. So what we know is that what we keep hearing about is that the industrial IoT plus other applications of Internet of Things is about to explode. Some of the data that we are seeing is quite mind-boggling in terms of the number of sensors. We're already seeing a lot of traction in the growth of these types of applications where different things are getting connected and more interesting use cases. Some of the more exotic ones, of course, being things like autonomous cars, but it actually spans across different verticals. Just in terms of the amount of data that we anticipate as a result of all these sensors being connected and being able to now have all this data at your fingertips. Some of the estimates that I come across in terms of social networks, the social media, what they say is created a zettabyte era, whereas with industrial IoT, we are actually looking at yottabytes. And just in case you don't know what a yottabyte is, it is 10 raised to 15 gigabytes, right? It's basically 1,000 terabytes is 1 petabyte, 1,000 petabytes is 1 exabyte, which is basically 10 raised to 9 gigabytes, but yottabytes is 10 raised to 15 gigabytes. What that means essentially is that all this data that is being produced at the sensors it's not going to be realistic to expect any communications network to handle all that data being constantly produced. So which means that we will see more and more requirement for processing the data as close to where it is being produced as possible. And that's essentially creating an interesting phenomenon, which is basically a lot of the great success that many of the leading cloud platform providers are seeing. Now we are seeing also the same players starting to become interested in more edge compute, edge processing type of applications. So in terms of the evolution of IoT over the span of the next few years, how do we at Intel see that happen? So broadly speaking, 3 categories of IoT, and not necessarily they're going to happen one after the other. They're not sequential. Most of these are happening in parallel as we speak, depending on what type of application you're looking at. What it means is that some of the more complex applications, they're going to become simpler over time. So you will see a shift towards the more autonomous direction increasing over the next few years. So these 3 categories are what we call as smart and connected things, connect unconnected, smart and connected things, and autonomous IoT. Essentially meaning that in the most simple use case is telemetry. You have something that is currently not connected, you add a few sensors to it, start getting data and understanding what's exactly happening with that real time. Some cool examples of that are if you have an earthquake prone area, you can add sensors to some of the critical infrastructure and now start collecting data real time, as opposed to having say semi-annual or annual inspections of these assets, which is also going to be a little bit error prone and human effort intensive. So with sensors, we can augment the human effort. We can actually make things more predictable, more real time, and that's one very simple use case. So with that, we see that information is collected, but how do we do something with that information? So that's where the next phase or the next type of applications comes across, which is to do with smart and connected things, which is about being able to not just collect the data, but also do something with that data in the form of being able to send some command back to the infrastructure. So as an example, being able to remotely control a pump. So very, very cool example. You may want to be able to control certain things remotely from your office, certain things at home, obviously assuming it's going to be safe. So security is a whole completely different and important topic, which there are other sessions about. But point here is that there's going to be communication from the assets. You do something with it, and then there's going to be communication back to the assets. So basically your sensors and your actuators that are going to work in tandem with what's being produced. The final most important shift that we are going to see in the next few years is the whole application of interesting uses of that data. So AI, as you know, is a very hot topic, and what that means is now we can actually almost in a brute force way, you can actually understand patterns, interesting patterns that are being produced across the different data sets, being able to understand get some insights out of those patterns, and then make things more intelligently act on their own. As an example, we hear all the time that this year, just in AI has been able to beat humans in facial recognition. And this trend continues. We are seeing computers and AI getting better and better at many tasks that humans have been traditionally better at, but now with the enormous amount of compute power, the amount of data that we can look across different dimensions, AI is becoming very, very prevalent, and it's going to continue. But what that means is all the data, the yottabytes of data that are eventually going to get produced, we need to be able to get insights out of that and make things more autonomous, which means that in the previous two versions which I showed, that was as things are getting more and more connected, AI is about having to rely less on the connectivity. And when I talk about connectivity, there are always in IoT, you'll see two types of connectivity. One is the local connectivity, or the field connectivity. Many times it is also called as a LAN, but actually that it is often used with IP networks, whereas in IoT you see all kinds of local or field networks like BLE, Wi-Fi, which is IP, but also things like LoRa or Sigfox, which happen in the local area, but then you also need connectivity to the cloud or some central place, which is the backhaul network. Often it is some type of a wired network, or in remote areas, cellular networks work great. In extremely remote areas where cost is not that much of a concern, some very high value applications can be like that. Satellite communication is also something that is used. So when we talk about autonomous, it is all about how can we get the data, generate insights, and then have those insights be available at your fingertips at the edge. So a classic example here in this case is autonomous driving. You don't want your car to go to the cloud every time it sees a pedestrian or something on the street. You want that car to be able to make a critical decision right there and then, even if there is no connectivity at that moment in time back to the cloud. Now, if the opportunities are so great, then why is it still taking time for IoT to get adopted at a broad level? And we see many challenges. For the most part, the biggest feedback that we have from our customers is the solutions that they have seen so far. They're very, very complex to implement. So sensors, you have to buy them from some particular vendor, then you have to figure out what connectivity is going to be used. There are software device drivers that connect to these types of sensors, different types of field buses, many, many technological challenges. Not only that, the standards are pretty much like there are 1,000 standards, which kind of defeats the purpose of having standards themselves, but they have evolved over time. So these standards are not going to go away or converge into a single standard anytime soon. So we have to live with that. But what that means is then that complexity is still exposed to the end customer. And a lack of combination of hardened offerings, which is somebody putting all these solutions together, the sensors, the software, the middleware, the connectivity to the cloud, in a way that makes sense, at a price point that makes sense, has not really taken hold all that much, which is another factor which is slowing down the adoption of IoT. So what we see is, as a result, slow time to market and even slower time to revenue, which means every time you have to deploy, it goes through several months of evaluation, pilot phases. Customers are worried about security risks. You have to address those, and that's what is taking time for the adoption. And this is exactly the challenge that we intend to address with our RFP-ready kits. So I'll give an example here. So so what I mean by RFP here is RFP stands for request for proposal, and an example of that is, let's say, a smart city coming out with air quality monitoring solution request, or an industrial customer wanting to do predictive maintenance, wants to proceed with some type of implementation. They first come out with an RFP. An RFP stands for, like I said, request for proposal. So they invite proposals from typically from various system integrators or SIs. So these SIs then respond to that RFP with competing bids, and then with details about how the their solution is going to work, how it is going to be able to provide the outcome that the customer is looking for. So very good example of that is, a few months ago, JP Morgan announced that they want to implement a building solution in across 4,000 buildings in the US. And if you look at some of the data behind that, it always presented as a business problem. So in that case, JP Morgan said that it is going to be, if they're at the current rate at which they're consuming electricity, their electric expenditure is going to be about $1.5 billion over the next 10 years. And they want to get a net reduction of $200 million after implementing an IoT solution. So when they say net reduction, it shows that they are intelligent enough to understand that any IoT solution is going to cost money to deploy, and not only deployment, but also an operating expense across those 4,000 buildings. And they want to validate whether a particular solution is going to work or not, which is why customers like that, they invite RFP responses. And then that process typically goes through a demo, then it goes through a pilot phase, where in this case, it could be 10 to 20 buildings that they test with. After which point they are comfortable that this particular solution is going to work for us, and it is going to generate a net positive ROI, return on investment, which then I can scale, as say JP Morgan, they can scale out to their 4,000 buildings. The time to revenue can be very long. In fact, what we have heard as feedback from our SI partners, system integrator partners, and also enterprise end customers, is that it takes anywhere between 6 to 18 months to just complete the pilot phase, after which the SI will start seeing the first dollar of revenue. And this is too long. This is actually an enormously long period of time, and not everybody has such deep pockets to go through multi-month or patience to go through multi-month cycles of sales cycles or validation cycles even. And not only that, it also reduces your ability to go broad market with going to a lot of different customers, because you can only do so many concurrent pilots at the same time. So the RFP-ready kits are intended to address this problem. So in fact, we want to reduce this time from 6 to 18 months, which it takes currently, to 6 to 8 weeks. And how do we do that? Because these kits, what you'll see here, are going to be focused. So all the kits that we are going to present, or we are going to onboard, and I'll explain what that means. They're going to be targeted at specific use cases. They are going to be domain specific. So you're not going to see any of these things that, okay, here is a generic chip, or here's a generic board, and you can do what you want with it, or here's a generic piece of software, a tool that you can do anything you want with it. Because again, unless it has the domain specific problem analytics and applications built in, it is of limited value. In fact, many of our customers have given feedback that I can do anything I want with this board or with this box, but I can also do anything I want without that box, right? So essentially, what they're saying is it has to have more than just the generic element to it. These are also customer proven, which means that these are deployment grade, is a commercial grade. You'll not see maker grade or hobbyist grade. So these RfP ready kits that we have, we are not targeting the education sector here, saying that, okay, let's teach school children how to do IoT. That is not this program. There would be, that is also a very important activity, but that is something, a separate work stream on that. So this is primarily targeted at commercial scale deployments. So this also means that the solutions that the customers expect have to be hardened. These have to have elements from sensor to cloud. It's not just one piece of the technology, but how everything integrates with each other. It has to be shown to be working with the major cloud platforms. The actual distribution, the commercial distribution and availability of the inventory, the pricing, the support, all of that has to be well defined. And these are the elements that make the solution or the kit repeatable and scalable. So what you'll see is that all these kits that I'm going to present here are available across the various use cases and available from various partners to purchase today. So the elements that we think, and the RfP ready kit is one of the elements of the deployment, but the various elements that you will see that being covered is how do we take an RfP ready kit for a given use case? How do we make it available through IoT solution aggregators? So when I say aggregators, these are companies which are very good at distribution, logistics, and fulfillment. Companies like Arrow or Synex and WPI, who are already major Intel partners, who can provide very rapid availability anywhere you want with the support that you need. In addition to that, there are major IoT platforms. We work with all the major platform providers, IoT platform providers, you name them, and we are working with them to make these kits very easily integratable with those platforms. And these end in market-ready solution offers, which are then sold typically by the SI. So when a system integrator is going to a customer with a predictive maintenance offering, that includes the services component to it, the operations aspects. So that is built on top of all these elements. So in terms of the Intel IoT platform architecture, what I just mentioned, so what you'll see across all the kits are what happens with the things, what happens in the network, essentially, like I said, the field network and the backhaul network, and there are things that need to happen on the cloud. So you'll see elements of all these three across all the kits, and then tied to a specific vertical use case that you will shortly see. So let's take an example from industrial IoT. Let's say you're doing predictive maintenance and there is an oil well. You know that, like we talked about, we know that every oil well produces roughly about 100,000 barrels per day per pump. And even if you capture data points at just 100 hertz, and this, just remember that when we're talking about predictive maintenance, it has to be, the data has to be at a very high frequency. Data has to be captured at a high frequency, because it is not just pure telemetry you're looking at. You want to also understand what's going wrong with a particular piece of equipment. So when there is a vibration or any kind of a sensor that you deploy, it has to collect data at a sufficient frequency to be able to make predictions out of. And that the faults can be at a very small time intervals, so you have to capture it at a very high frequency. So deploying a small number of, even just a small number of sensors capturing data at these rates, you're going to start seeing enormous amounts of data being produced. Now, all of that data cannot be sent to the cloud all the time, because in oil fields, like in most scenarios across the world, connectivity is not always predictable, and not only predictable, but also not very cheap. So I'm sure my cell bill is quite big. So I can imagine in use cases like this, for example, in agriculture, when we're speaking to one farmer, his monthly bill is $24,000 for just one part of his farm, because he's sending a large amount of data. And in that case, it makes sense to do that if you're actually capturing that data to predict, say, the maintenance of a large combine. Similarly, in this case, from an oil field, you are looking at large data rates. And not only that, we are seeing more and more applications of video. because video is the ultimate sensor in many respects. You can actually capture, you can use video or computer vision to track assets for physical safety, worker safety, to also check on theft. It's a very versatile sensor, but it also generates a huge amount of data. And if you really want to be efficient with that, you have to actually process the data stream right at the source. So rather than sending an HD video feed back to the cloud, if you can analyze and see only flag patterns that you don't see as normal, so any anomalous patterns, you send it back to the cloud, that becomes a much more compelling use of compute power. So you're essentially using higher compute power to reduce your burden on the connectivity. You'll also see in industrial that it's all, and across other use cases as well, that the customers are largely interested in retrofitting rather than replacing existing equipment. This is a problem which is very stark in healthcare as well as industrial, because if you have a $4 million gas turbine, you cannot replace it every year. You have to, it has its own life cycles. You have to basically keep on upgrading, maintaining. And then it's about how do I, without disrupting any of my existing applications or operations, how can I add more sensors to it? So that type of mindset is very important. So the kits have to be able to take existing infrastructure and add on to the top without changing anything underlying, which is a very important factor to remember here. And this is actually applicable across a lot of industries that we see. So we have different kinds of assets. These are analog and digital, and these are not just the assets that we're talking about in complex operations. You also have to think about the human aspects. How do people interact with these machines? So you have to capture and make people capture the data and make people part of the workflow rather than keep them as separate. And that's exactly what, when we hear about IT plus OT integration, that's exactly what it means, that you have to combine the field operations, the people, the workforce automation, all of that has to be combined in a seamless fashion across the solution. So once that data is captured, you have typically on the cloud, and very often in industry, we're still seeing a lot of customers not very comfortable with public clouds. They want to have their own private instances, not necessarily on-premise, but still the private instances. Some of them also have on-premise, depending on the level of security required, which generates interesting problems in terms of how do we keep it up to date, how do we get the best applications and maintain the life cycle of those applications remotely. So this on the cloud, you'll see that we very often in industrial remote monitoring and diagnostics is a big area of interest, where you should be able to remotely and at real time monitor your industrial assets. Also seeing more and more applications of deep learning. Many traditional predictive maintenance products have relied on classical statistical methodologies for predictive maintenance, but now we are seeing with increased compute and capabilities, deep learning is more flexibly applied, which allows you to actually change the algorithms much more rapidly. The development cycle for those algorithms is shorter, assuming you have a good quality data, which is what we have to then start focusing on in IoT. So to tackle this problem, this is an example of a kit, and I'll give you a couple of other examples as well. So this is from one of our partners called NEXCOM. It comes with a set of Intel-based hardware, certain software. We also help put together these, help our partners put together these kits with Intel IoT technologies. This is intended for rotor vibration analysis, this particular one. As you can see, the different kits have different price points, and in this case, if you're looking at a very expensive asset, comparatively, this is a pretty affordable kit for those types of use cases. But in other use cases, you might require a different version or a different kit, and we do have across partners a lot of different types available to us. So when we do get an RfP that we hear about from one of our SI partners, we actually work with our existing partners who have these kits to provide the SI with the right type of a kit for a given customer problem. That way, it helps them answer the RFP in weeks rather than months, as well as it helps our partner to get their products appropriately positioned with the end customers. So far, so far we have about 19 kits we have onboarded. Essentially, think of it as two different tracks that we have. We have existing kits that our partners have already worked on with Intel help on creating across different verticals. And there are other partners who don't currently have kits, but are very interested in building Intel-based kits. And so we want to help partners, possibly partners such as yourselves, right, to create new kits in certain use case areas that currently are not addressed, or even if they're addressed, we would definitely want to see if there is any differentiating aspect. Definitely, that's some area where we could work together. But the first track is about, if you have an existing kit, we go through the process. We make sure that it satisfies the criteria for RFP readiness, whether it is really ready to go to our end customers RFP and answer that. Or the second track, which I mentioned, is if you are interested in creating a new kit, and you don't know where to start, how do you use Intel hardware, how do you combine that with other Intel IP, software IP, firmware, those types of things, and create for a specific interesting vertical use case area. That's another thing that we'll be very interested in talking with you. We have 19 kits across different verticals. I'm not going to cover every single example. I'll just take one or two and then go into a case study where we actually worked with one of our local partners to put together this kit. So this is an example of that kit. This is one of our local partners in the Bay Area and in the Silicon Valley. They came out with this agriculture kit, which is intended for doing remote monitoring of farm equipment or farm conditions. And not only just monitoring, you can also use that for actuation. So think of it as, out of the box, it comes with soil moisture sensors. It is very easy to add other sensors to it, connect that with other actuators, and you can plug it into an automated or an electronic irrigation system to make it an autonomous irrigation system based on conditions, based on weather predictions. They have the APIs to customize it. So what it comes out of the box with in this case is the sensors. This is what we call as the sensor hub. This is the Intel-based gateway. There's software running on this, aggregating data across various sensors. And that is what is used for making local decisions. And then you can also develop your applications on top. So literally, I mean, when I talk about a kit, the user experience and why this is so easy to use is that, and this is the user experience we want to provide across all the kits. Essentially, when you buy this kit, it gets shipped to you with all the stuff that I mentioned here. And there are 3 steps to start using it. You plug in the power, you plug in the network, and you press the on button, and that's it. The data starts showing up on the cloud. You can also access the data locally. If your cloud connectivity happens to break for some reason, you can also access it directly from the gateway with a web-based dashboard. So this is the type of user experience and simplicity we want to drive across all the kits that we have in our RfP ready portfolio. Another example, this is a computer vision kit. This is, as you can see, it can start at a pretty compelling price point for many types of use cases. But you will rapidly realize that once you start getting into more advanced use cases, you will need better processing. You might need better cameras, and those options are available as well. But what this comes with is camera with certain unique capabilities like depth sensing and others from a company called Bachelor. That's one of the elements of that kit. Sorry, it comes with the Pylon's API software that you can use to program for computer vision, and it comes with this board called the UP board. The next version we are working on is based on a higher end processor for more complex applications. That's called UP squared. But this comes from a partner called AAEON. This is available to purchase today, and we will show. If you have any questions, just ask me. I can point you some information that where you can purchase this and so on and so forth. So how does Intel help? So Intel, if you have a kit that you want to onboard, or if you want to work on a kit from scratch, so Intel helps with both the get to market and the go to market aspects. So when I say get to market, what are the priority use cases that we are seeing a demand for from the market? How do we build? What is the value proposition for a kit? What types of business challenges do our customers have to solve that problem? And not only that, once the kit is ready, or even like from a technological perspective, we have elements of technology that go inside the kits, and I'll show you some examples. But there are also go-to-market activities that we help with, things like recommending these kits, having joint marketing, co-selling, co-marketing type of efforts. We are working, when we work at different events, industry events, we actually like to work with our partners to showcase their solutions. So there's a lot of co-marketing, co-development, and co-selling activity that can be part of either the get-to-market or the go-to-market side. So I'll jump into a case study here, where we will talk about a little bit more about one particular use case, which is agriculture. I spoke in brief about that. So in the example that I showed you earlier, the partner developed kit, ATOMITON, this actually addresses the macro problem of being able to get better productivity and yields out of farms. So it's not just about saving water, but it's also about increasing yields of the farms using the optimal amount of water. And it contains, in this case, I mentioned earlier, this is our kits have to be sensor to clouds. This actually contains all the elements: sensors, sensor hub, the gateway, the software, and the cloud integration. All of this in this particular kit. So the macro problem is, of course, we know that population is set to grow to, or projected to grow to about 10 billion by 2050. The food production needs to go up by 70% in that period, but we are currently only growing at about 2 to 3%. So we need to have a dramatic improvement in the way we grow things. Sorry, this is jumping for some reason. So we are actually looking at this type agriculture as one of the strategic use cases, and one of these partners, they are actually created this kit in that domain. So what happens is, when you take this kit, you actually get the sensor hubs which get deployed in a farm. So this is an actual deployment. The map that you're seeing here is it spans about a mile by a mile. 1 square mile is 640 acres. And that actually, the part that is cultivated is just about 350 acres, which is average by US standards. So these sensors get deployed in these fields, and they communicate over LoRa to the gateway. LoRaWAN is an unlicensed band protocol, LoRa, which actually runs at very low power, and you can get extreme range out of it. So these sensor hubs, which communicate with the base station, actually can communicate over multiple protocols as well, like Wi-Fi or Bluetooth, but those are not that commonly usable in agriculture. The backhaul in this case is a cellular network. This gateway actually is cellular capable, so you just insert a SIM card. Locally, it can support LoRa and Wi-Fi, and you can communicate with the cloud over the cellular network. Most farms that we know that we have worked with, they don't have broadband connectivity on the farm itself. So this is how a typical deployment looks like. This is from the actual farm. And once you plug it in, you can also have there's also an option to add solar panels and many ways to extend the kit. You can integrate with weather APIs and provide more applications. So the SIs typically take these kits, they develop their custom applications on top using the APIs, and then they provide that as a solution to the end customer. So in terms of working with Intel, if you already have a kit that you think is a good candidate, submit it to us. The site is provided here. You can submit it for a review. Our team will assess it. We will approve it, or if we see any gaps, then we will work with your team to address those gaps. And then once it is approved, then it goes to our internal and external sites, and then we can start working on providing better insight how we can start working with our SI partners on getting actual adoption, market adoption for those kits. But that is not enough, because like I said, the kits may work at low volumes, but when we have a large customer opportunity, you do need ability to somebody to stock inventory, somebody to be able to provide local support. So as an example, if this agriculture kit is deployed in Malaysia or Australia, the best way for customer to get support is locally over there. So we're actually working with our IoT solutions aggregators, and then they are working on providing the inventory, stocking up the inventory, providing local support and things like that. So companies like Arrow, Synex, WPI, they are our first phase of solutions aggregators. They are the ones providing support for these kits at scale. Now, if you have some interest in building a kit, how to create a new RfP ready kit, the best way to start with that is to go to our Intel Developer Zone, and we have recently come out with an announcement on how do you start commercial grade, how to start developing using Arduino type of experience on commercial grade hardware. Many of the maker grade hardware is not actually able to withstand actual physically challenging deployments like harsh temperature conditions or other things like that. But this, for the first time with this platform, you're seeing the same experience, same developer experience now come to commercial grade hardware. Also, another advantage is that the hardware that ships out of the box with some of the early kits is actually standard Intel IA64, 64-bit. Works on standard Linux, so there is you can actually run any standard 64-bit x86 binaries on the same platform, along with the Arduino compatible sketches that those boards have. So those are the types of things that are possible. But essentially, it involves the process involves something like this. You would need to have some kind of an ODM hardware. ODM stands for design manufacturer. We actually have a large portfolio of ODMs. Some of the ODMs you already seen are customers such as Advantech or NEXCOM. In the case of the predictive maintenance kit, that's an example of an ODM. They make ruggedized hardware for given applications. So you may have an industrial grade gateway, which is at a certain price point, but not all use cases require that. So they all have a variety of different types of form factors. That's just one ODM, but there are many others. Then you identify for your use case the sensors, the actuators that you'll need. And if you are an ISV, if you are a software company and want to create an IoT kit, then our recommended path is to pair up with, and we can help with that, pair up with some hardware provider, commercial grade hardware provider. Use the Intel content for automating some of the deployments for remote management. We have some security stacks, and then combine that into your kit, and that becomes your RfP ready kit that we can then onboard at that point in time. Very often there is additional development required, so it's not just, if you just are a software company, pure software company, to provide the kind of user experience that I mentioned, things like being able to plug and play, just plug in, turn on, you should start seeing data across different customers. That's something you may have to develop. If you already have that, that's great, then we can just quickly onboard that. Some additional resources, and that's my last slide, at which point I will jump back into the video to go over the questions and answers. So one question I'm saying is, does the gateway provide local intelligence? So the answer is yes, absolutely yes. That is the intention. And the way you provide local intelligence is over two means. One is to have local intelligence. You still need to know the difference between what's local and remote. So what I mean by that is your insights will be produced over analyzing large amounts of data, aggregated over multiple data sources. So that analysis will happen, learning or analysis will happen typically in a very powerful infrastructure. And then once you have generated a configured network, for example, neural network, or extracted some insights out of that large amount of data, then you can actually take that and you can remotely deploy it using some of our tools to the edge, to the gateway that is sitting at the customer's premise. And then it can start looking at the data that is being produced at that particular site and applying that intelligence to that particular customer's situation. Second question is, can you provide details of the gateway? So the gateway is not just one particular device. It's actually a class of devices. So it actually, these are, you can say, from Atom to Xeon. You have different versions of the gateway. These examples of, so for example, like the agriculture kit, actually the one which I showed comes with comes from a company called Advantech, the gateway itself. But all of that is bundled together. So if you are using this kit, you don't have to worry about, okay, who is the manufacturer? Do I need to talk to the manufacturer of the gateway? Actually, you just need to look at that kit as one single thing. You buy it from the company which is making that kit, and then all of it is, all the software, hardware, sensors, everything is bundled in that kit. So that's one of the examples. Like Advantech happens to be that particular in that particular kit, but in the industrial predictive maintenance kit which I showed, that's another company. It's a different gateway that comes with an i7 class processor, which has much higher capabilities for addressing predictive maintenance in industrial settings. So that's the one. So another question is it similar to AWS Greengrass? So AWS Greengrass is one software layer which provides Lambda or serverless compute functions at the edge. So it is complementary. It is not similar. So AWS Greengrass is a software stack. It requires some physical infrastructure to run on. And that physical infrastructure typically comes from one of these kits. So think of, say, taking one of these kits and being able to run AWS Greengrass as well on top of this existing kit as a software, as an additional software capability. And then you can deploy Lambda functions in addition to other things that are already part of that particular kit. Okay, so another question, is Intel developing the kits, or is the development of kits outsourced? So Intel is actually, our philosophy is to provide the technology inside. It's more of an Intel inside philosophy, where we create underlying technology, starting with very seemingly simple sounding things like, okay, somebody creates a new device, a new hardware. First thing it has to do is it has to boot up, right? If you have to run Linux on that, it doesn't happen automatically. There has to be some development to be done for that. So Intel has actually a lot of capabilities in all the way from device design to firmware design, implementation, booting up, hardware optimization for things like getting maximum performance out of it. So we are actually one of the largest contributors to Linux kernel, as an example. That's just one example. There are many other things that we also do. Communication stacks, the software stacks, the remote management for thousands of devices deployed across various customers. Being able to provide security. Those are the types of things that we have, which actually get embedded inside the kit. So these are not, you'll not probably see too many Intel branded kits out there, but our philosophy is to help our partners create these kits, and we help them put it together, which they can start selling to the SIs or to the end customer. Okay, so another question is, what areas do you see RfP ready kits being developed or needed? So that's a great question. What are some of the priority use cases that we see in the industry? So far this year and going forward, the three areas that I see maximum demand coming up is number one, predictive maintenance or industrial kits, RfP ready kits. Second is to do with computer vision. A lot of people are starting to see more and more applications of computer vision. So you can deploy it in the homes, you can deploy it in factories, you can do it to use them to measure things visually. So many versatile applications. And the cool thing is that the same camera can be used for doing so many things. With a temperature sensor, you can only do one thing, to measure temperature. But with the camera, you can actually, with just a software update or with just some additional software capability, you can do many more things that were not possible earlier. So that's computer vision is second, and the third one is to do with tracking movement of things, either within a location or across geographies. So package tracking is a very crude way of saying it, but more importantly, even within a location, things like, say, in a hospital, if you have a defibrillation machine, if at any given point in time you don't know where it is, and if you have an emergency, then you're going to start scrambling to find out where it is. So seemingly simple, but actually these are pretty hard problems to solve, especially how do you locate something indoors. So that's another, in this case, a good example. But indoor tracking is just one type of location or asset tracking. Is many variants of that are also coming up with customers. I guess that's it. Thank you.